Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle. And it's called That's 3 in the Center. Not in the corner, in the center. That's 3 in the Center by Proxy 14. Here are the rules. We have chaos construction rules, where we need to divide the grid into 9 regions of 9 orthogonally connected cells. And we must place the digits 1 through 9 once each in every row, column, and designated 9-cell region, which we construct. And an orthogonally connected region must basically mean, it means that the cells all can go to any other cell in the region just by going through edges and staying within the region. This is a valid orthogonally connected region. This, however, is not, because this cell, trying to get to any of the other cells in the region, must either go through a corner or must cross into another region, which is not valid for the orthogonally connected region. This is also not a valid orthogonally connected region because these two cells, even though they can connect to each other just by going through edges, cannot connect to the rest of the cells in the region by going through edges while staying within the region. And that's chaos construction rules. We have crop key dots, where digits separated by a white dot are consecutive, and digits separated by a black dot are in a 1:2 ratio. So, for example, if this were, say, a 6, an orange there in that case. If this were a 6, this would have to be 5 or 7 to make sure that these digits, actually, let's make this digit a 6. If this is a 6, this has to be 5 or 7, and this to be consecutive, and this would have to be a 3 to maintain the 1:2 ratio between them. And that's examples of how crop key dots work. We also have clues outside of the grid represent the size of the largest consecutive set of cells that belong to the same region within their row or column. So this 6 is saying that the largest contiguous consecutive set of cells that belong to the same region must be 6 in this column. So you could have 6 here, and these are in the same region. You could have 6 here, and they're in the same region. That's all valid. This would be 4. There are 4. The largest consecutive set of digits here in the same region are 4. So you could have 4 here, and that would be in the same region, and that would be valid. For column 2, it's only 2 cells can be in the same consecutive sets and in the same region. So this could be 2, but this would not be valid because that's 3 consecutive sets all in the same region. So that's what the clues outside the grid represent. And finally, we have region sum lines, where region borders divide the lines into segments with equal sums. And each line must go through 3 regions without entering the same region twice. So that means every line in this grid is a region sum line, and they must go through at least 3. Oh no, they go through 3 regions. Exactly. You cannot have more than 3 because it says must go through 3 regions. And you cannot enter the same region twice. That's interesting. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, we know in columns 5 and 9, the largest consecutive set of cells that belong to the same region is 6. Therefore, we are guaranteed this has to be at least 3. Because it's either 6 here, 6 here, 6 here, or 6 here. So these are 3 guaranteed to be in the same region. And these 3 are guaranteed to be in the same region for the same reasoning. We have a guaranteed 4 here. If there could be 4 here, and this is 6 here, right? That's possible. But that's interesting. We know each region's sum line divides the line into segments with equal sum. So these have to be the same digits no matter what. So these are the same digits. So this is A, we're going to mark this as A, this is B. This has to be A, this is A, this is B and B. So these have to be the same digits. That's interesting. Okay. Well, we don't know what regions these are, though. Right? So these could be the same region here. We know in column 2 and 8, 2 is the most that each region can be in that column. We have 5. Oh, 5 in rows 7, 8, and 9, which means these must be part of 5 consecutive cells each in this region. Therefore, we know this cannot be pink. If this were pink, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 at least, guaranteed to be in that region. And the same for all of these. So these are all the same region. So we're going to mark this actually as medium gray. This then is a boundary. So this is a boundary here. This must be part of 5 as a region. And it could be part of another part of 5 with that region. So that's possible. So we know there's a 5 here. This is part of that 5 region. This is part of that 5 region. And this is part of those 5 regions. And the 5 regions could actually be connected. So we don't know. This has to be 6. This is separate than this region. So this is not the same. This is not the same because it's part of a separate region. This could be part of it. We don't know. This could have 4 here. That's fine. This could have 4 here. This could have 4 here. We don't know. These are in 1 to 2 ratios, though. So they must be... This can be 1, 2, 4, 8, which makes this 1, 2, 4, 8. This could be 6, and this could be 3. This is in a 1 to 2 ratio, but it's not 3. So this is, again, 1, 2, 4, 6, and 8. This can't be 6, because that would be in a 1 to 2 ratio with 3. So this is 1, 2, 4, and 8 here. This is consecutive with that. So it could be 1, 2, 3, 5. So 1 and 2 could be with 1, 2, or 3. 4 could be with 3 and 5. 8 can be with 7 or 9. That's interesting. 1, 2, 3 can be next to 1, 2, and 4, but it can't be 3 here. 5 can be next to 4 and 6. 7 can be next to 6 and 8. 7 and 9 cannot be only be next to 8. 1, 2, 4, 8 is next to 1, 2, 4, 8, which is next to 1, 2, 4, 8. So those are all possibilities. One, 2, 4, 6, and 8. 1, 2 can be next to 1 and 2. 4 can be next to 3 and 5, but it can't be 3 because of the 3 in the center. 6 can be next to 5 and 7. 8 can be next to 7 or 9. Okay. So each of these centerpieces is part of the 5. We don't know where the 5 is, though. Hmm. 2 of these digits along the 4 length region sum lines must be the same. And then there's another 2 that add up to those 2, right? Let's see. So if this is 4, I guess it could be 4 this way too. Okay. These must go through 3 regions. Huh. One thing you cannot have is you cannot have 2 in the mid. No, you could have 2 in the middle. Never mind. Hmm. If this is 5 this way, that means this is guaranteed 6 here. So what happens if that's okay? Well, 5, it cannot connect to. Oh. Well, but the thing is, we know this is guaranteed 5. That's why we knew this was 6 this way, right? That's interesting. For the 4s, that means if they're not part of the gray cell, one of them has to. Well, I guess they could both be here. They could both be on the same side. That is possible. One thing, do we know? I don't even know if we know. Do we know that it has to be 2? Cannot be 2? I don't know. These are in a 1 to 2 ratio. This cannot be 3. This can't be 3. So this can't be 3, 6. So this is 1, 2, 4, and 8 here, which makes these 1, 2, 4, 8 here. Interesting. Huh. I'm not sure what that tells us. Tells us something. These digits are consecutive with 1, 2, 4, and 8, though. So it could be 1, 2, 3. 4 can be consecutive with 3 and 5, and 8 can be consecutive with 7 or 9. This could be 3 and 6 here. We don't know. So it's 1, 2, 3, 4, 6, or 8 as possibilities. These are consecutive with 1 through 5, 7, and 9. We have all the digits here, interestingly enough. Can this ever be the same as that? Yes, if this is 1 and 2. Right? 1, 2, and 1 is fine. Or 2, 1, and 2 is fine. Same with this, if this is 1, 2, and 2. Remember, two of these have to be the same digit, at least. Well, no, exactly two have to be the same digit along a 4-length region sum line, which must be in 3 specific regions. Obviously, the ends could be the same. So can this ever actually be 9 in the middle? I don't think so, right? It would have to be 9 on the in the middle and 9 on the outside, which is not possible. Okay, so can this ever be 7 is kind of the question, right? 7 here would require this to be 6 and this to be 3. But 3 and 7 doesn't add up to a single digit. And 7 by itself cannot add up to 3 as a single digit, so no, this cannot be 7. 5 could be there. No. That doesn't work either. So this can't be 9. Same thing. 9, 8, and this is 4. And then the 4 and the 9 cannot be part of 3 regions. Same with 7. 5. What about 5? Does 5 work? 5 would have to be next to 4, which would be next to 2 or 8. So that is possible. Okay, so what are the possibilities? The two ends here are the same, or these two are the same. 1 and 2 the ends cannot be the same. If the ends were the same, it's only 1 and 2, right? If you try to have anything else, say 8, 4, and 5, those aren't the same. 4, 8, and 7 or 9, which is not the same, so this can't be 8 anyways. This can't be 8 to be consecutive with this digit. 4 with 2 and then 3, those aren't the same. So the ends have to be the same here. So this must be C and C, and they must be the same. And the middle digits must add up to them. Because if you tried 1, 2, and 1, the middle two digits are in the same region, but they can't add up to 1 or 2 as 2 digits. So that's the reason why that doesn't work. So the ends have to be the same. They must be at least, this has to be the same. So they're 4 and 8, which is in a 1 to 2 ratio with 2 or 4. So 2 or 4 is consecutive with 1, 3, or 5. Therefore, it's either 1, 3 or it's 3, 5. Either way, 3 has to be one of those two digits. Two and 4 can be consecutive with 1, 2, 4, and 8. So 4 has to be one of these digits, which means this cannot be 4 here. 4 has to be one of these two digits, which means 4 cannot be one of these digits here. So this cannot be 4. This cannot be 8. It's either 1, 2, or it's 3, 6 here. 2 and 4 is only consecutive with 1, 3, or 5. So if this is 8, this is 8. These would both be 4 and 3 and 5 next to it. If these are 4, these are 2, and you have 1 and 3 next to it, and that's possible. Huh. So this is 1, 3, or 5. 2 and 4 cannot be the singleton, I believe. No. If either of those are the singleton. So these are the same region. And these, we're going to mark these as light. And this is we're going to mark as green. And this, I don't know, pink, or it could be gray. Um, this cannot be a singleton, or 2 or 4. If this was 4, this would have to be 4, and then the other 3 digits would have to add up to 4, which is not allowed. Same with 2. So these must be part of another region. So either these two sum to the same number or these two sum to the same number. Either way. That's interesting. Hmm. What about these? We don't have any real restrictions here. So if this is 1, 2, and 3, it could be with 1, 2 here. These could very well be the same digit, and then these two add up to it. That's interesting. If this is not the same as this, that mean can these two add up to this? Maybe? I don't know. So, this could be 4 by itself, though. Oh, can this ever be 4? I think the answer to this is no, as long as it's not gray. Or medium gray. If this is 4, this is a separate region. Well, I guess it could be 3 here, and this is part of that. Okay, so never mind. That could actually work. Hmm. Can there ever be a 4 here? That actually is interesting. If there's 4 here, what does that mean for this? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This could add 3 cells, and this could add 3 cells. So that could form... Ah, there's 2 regions here. Guaranteed. Well, this could add 1 here. Or it could go... No, these has to be separate regions. So this would have to go... It's possible. So there have to be... This has to be part of these regions. Cannot be part of the gray region. So this would be part of the same region. This would be part of the orange. Oh, that doesn't work. That does not work. Okay, so again, if we have 4 here, if the 4 are here, this is a part of the 6, right? So there's no more extra orange cells. We have 15 cells which are blocked off by the orange and the medium gray. The problem is there are 2 regions here, but there have to be 2 regions because this can't be orange and these can't be medium. So these have to be 2 separate regions. And those 2 regions don't have enough to add up to 2 full regions because it's 15. Because the orange, again, is full with this 4 and whatever 6 is here. So this can never be 4 oranges here. Well, I'm curious now if we have something that's just separate here. Can it be like green? Maybe. This could be part of the medium gray region. Um, so that's possible. Or the gray could be part of a region, right? Obvious. So if the gray is part of a region, it has to be these 4. Because it cannot be part of this region, because again, each region's sum lines cannot enter the same region twice. So it would be here, here. So the 4 block in row 5 has to be either this, this, or this. Either way, these 2 are in the same region. That's interesting enough. Hmm. Hmm. Interesting. Oh, this cannot be 1 and 2. If this is 1, 2, that eliminates 1 and 2 in the rest of the row, which means these 3 digits would have to be a 4, 8 triplet with 3 cells having to have 4 and 8 in them, which is not allowed. So this cannot be 1, 2. This can't be 1, 2. This is 5, 7, 9 with 6 or 8, which must be consecutive with 5, 7, or 9, which must be consecutive with 4, 8. So this is 4, 8. This can never be 1. It could be 2, 4, 8 here. So these 2 can never add up. They must be the same digit then. Well, this could be the sum of these 2, and then this is the same. That's interesting, actually. Anyways, what does that mean? If this is 5, 6, you can't have 7 here. It'd have to be 5. So 5, 6, 5, 4. You could have 2 and 3. That works. 7, 6, 7. It could be 5. 7, 6, 5. So 7, 6. Obviously, these could be the same. So 7, 6, 7. These are never the same region, so we know there's a boundary here, period. So there's a boundary there. 7, 6, 7, which would force this to be 8. 4 and 3, that works. 9, 8, 9, 8, 4, and 5. These are consecutive. That's interesting. Oh. Okay, so this can't be 5, 6, 5. If this is 5, 6, 5, this is 4, 2, and 3. 3 is only consecutive with 2 and 4, but they're both here. So this cannot be 5 here. 7, 6, 7, 8, 4, 3 works as long as this is 2. 7, 6, 7, 8, or 7, 6, 5, 4, 2, and not 5, this is 7. So that's possible, right? 7, 6, 5, 4, 2, 7. So again, we tried 5, 6, 5, 4, 2. That becomes 3 to add up to 5, but the problem is that these don't add up then. I mean, sorry, this is 3 is consecutive only with 2 and 4, and this has to be 2 and 4 specifically. So that doesn't work. 7, 6, 5, 4, 2 works as 5 and 2 add up, and that's 7. 7's consecutive with 6 or 8, and both of them can be there. 7, 6, 7, 8, 4, 3 works with that being 2. 9, 8, 7 doesn't work because, yeah. So it would have to be, if it's 9, 8, and 9, this is 8, this is 4, this is 5, so this would have to be with 6. Interesting. But, okay. If this were 9, so if this is 9, this is 8. This can't be 7, 8, and 4. 7 and 4 don't add up to 9. 7 by itself doesn't add up to 9. So this has to be 9, which makes that 8. This is 4. These two must add up to 9, so this is 5. This 8 forces this to be 4, 2, which means this is the same, 4 and 2. So this cannot be a 1, 2 pair. It must be 3 and 6, but this 5 is only consecutive with 6. So 9 does not work. Therefore, this is 7. This cannot be 7. This is either 5 or, sorry, this cannot be 9. This is 5 or 7. 4 can never go to 8 here. That's too large. So one of these is always 4. 4 and 8 can go to 2, 4, and 8 here. This is 7. So 5, 2, and 7 works. Okay, so what are the possibilities again? 7, 6, 7, 8, 4, and 3 works as long as this is 2. 7, 6, 5, 4, 2, and 7 works as long as this is 6 or 8. Okay, so that's fine. And this can never be 5. Right? 7, 6, 7, 6, 5, 4, 2, and that's 7. 7, 6, 7, 8, 4, 3. Okay. Interesting. What else do we have? Okay, so if this is 8, so say this was 7, this is 8, so this is 8. None of these can be 8. This can't be 8. 8 can only be next to 4, so this is 4, this is 4, this has to be 2. which means this is a contradiction because it can't be 1, 4 as a 1, 2 pair in a 1 to 2 ratio. So this can never be 8 going to 7. This has to be 6. Can you go to 7 here? 7, 8, 4, 4. This could be 2 or 8, so that's fine. Yeah, and this is 3. That would be 2 then. So that's possible. Or if we go down to 6, this could actually still be 6, 7. Can it ever be 8 is the question. I think the answer is no, right? It forces this to be 7. This is 8. This is 4. This is 4. This is either 2 or 8, cannot be 8, but this would be a 1, 4 pair, which is not a 1 to 2 ratio. So no, this cannot be 8. This is guaranteed to be 6. This could be either 5 or 7, I think. So 7, you go to 8 here, 4, 4. This adds up 4 and 3. This must be 2, 4, and this is 2 or 8 here. And that's fine. Or if this goes to 5, this is 4. This is 2, this is 7. This is 6 or 8 here. This could be 2 or 8, which goes to 1 or 4. And that's fine. So this is 7 and 6 guaranteed here. The remaining digits in row 5 have to be 1, 2, 4, 5, 8, and 9. So B is 1, 2, 4, 5, 8, and 9. 1, 2, 4, 5, 8, 9, but it cannot be 4 because one of these two is a 4. So that's 1, 2, 5, 8, 9 here. If this was part of the gray, they have to each be part of these digits here, right? Because these 6 digits are already in the region. So these 3 digits are the ones that are left over in the gray region. So if this is part of the gray region, this must be a 7. This must be 6, so that makes a 7. This then has to be 2. This is 4. This is 5. So these are part of the same region. Oh, that's interesting. Okay, so these are part of the same region. And it's either here or here. We need a 2. This is 2 or 8, so this is 1 or 4 to be consecutive in a 1 to 2 ratio with this digit. So this must be the 2. So we know these 3 are guaranteed to be in the same region. So this is in the same region also because of the way that this works, right? Now we don't know if these are the same, but it's either these 4 or it's these 4. Technically, this could be part of this region, I guess, yeah. So this is 3 here. Hmm. Let's see. Do we have any other information? Oh, so this is interesting. So what happens if this is part? So say this was all part of gray. Oh, this is a singleton. And it's 2? That's not possible. So this has to be part of a separate region. Okay, so we know... Right. This is part of a separate region. I think it's probably green. Hmm. Right, and the reasoning why we know that. So assume this was the gray region, right? These 3 digits must be the same as these 3 digits here. Well, this must be 6, this must be 7. This means this has to be 7 to be consecutive with it. That means these two add up to 7. So this is 2 and 5. 2 is in a 1 to 2 ratio with 4. So this is 2, 6, 7. Therefore, this is 2. This is the only digit that's in that region. So the 2 digits that are in the same region that add up to it can never be 1 and 1 because that would have a repeat in the region. So that's why that doesn't work. So I'm guessing this is... We're going to mark this as green. Maybe we should change this to a different color. I don't know. Dark for now. We know these 4 are the same region. So this is a boundary here. This could actually be part of that region, of the gray region. The green could go multiple places. It could go here. It could be part of this region. We have at least 3 regions here, though. Right? We have 1, 2, and 3. Oh. Interesting. So, can this light gray region ever not be part of this line? And the answer to that is no. Because if we try to not be part of that line, it's only 8 cells wide. So this light must be part of this region here. Well, we have 1 and 2. It cannot be part of this 5 region. It could be part of this green region, so that's possible. But it cannot be part of the same as this medium gray region, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cells in that region if that were to combine. So light is not the same as medium. It could be the same as green, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 is totally valid. But we know we have 3 regions here. One of them can be green. The other one is contained. One of them's green. One of them is gray or medium gray, and the other one can be contained within this region. What you cannot have is you cannot have 2 regions for 2 separate regions which are not gray or green in that region. And the reasoning is gray has to be part of this. Say it was part of green. Actually, maybe that could work. That actually could work. Maybe. 1, 2, Okay, this can only be part of 3 regions. Gray is part of it. So if gray and green are the same, that means pink could be part of that. Okay, so if gray and green are so only if gray and green are the same. If gray is different from green, gray by itself has to have 9, and then there's no other space for another region. So, I mean light gray, sorry. Light and green. If light and green are the same region though, pink could be its own separate region. This dark could be its own separate region, potentially. No, it can't. It has to have 1, 2, 3, 4, 5, 6, 7, 8. At least in that region. Therefore, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for 2 regions. No, that's not going to work. So, light cannot be part of the medium gray region. Therefore, this pink, again, you cannot have two regions. So remember, we're trying to have it, first of all, okay, it can't be obviously none of these 3 regions on this line. At least one of them has to be green or medium. So we tried it without it just doesn't have enough space, right? There's 16 cells. You can't have 3 regions covering those 16 cells. Well, we tried it, though, with light potentially being part of green, right? So that medium, we're just assuming medium is never part of these 3 cells here. But that doesn't work either, because the light can never be part of medium, just in general, because that's 4 digits, 4 cells to connect to it. So that's 10 cells in total. So that can never be part of medium. What if light were part of green? That would be 8 cells. But then that leaves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cells for 2 separate regions, right? We're assuming that medium gray was not part of any of these 3 regions here. And that doesn't work. So again, light cannot be part of medium. If we try to have light here and light be part of the green, well, what if dark is part of the green? 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 for 2 separate regions. So that doesn't work either. And if pink is the same, it's the same problem. So we know dark, medium, and pink have to be part of green, its own region, and medium gray, guaranteed. But we don't know which one's which. We do kind of know, actually. Dark cannot be part of the same region as medium. That's too many cells to connect to it. Same with light. So therefore, medium must be the same as pink. So this is medium. Light could be part of green, or dark could be part of green. We're not sure which one. So light has to be part of this third. This could be a separate region. It doesn't actually have to be green. It could be like some red region down here. So we don't know about this. So either this gray is part of a 4-cell region, or the 4-cell region is here. That's possible, though. This cannot be a separate region on its own. These have to be the exact same digit. If this is 8 and this is 8, this is 4 and 4. If this is 4 and 4, this is 2 and 2. So these cannot be in the same region. Okay. But they are the exact same digit. That's interesting. They cannot be the singletons either. Because if there are the singletons, then you break up this into 5 regions, which is not allowed. So they must add up with another digit to add up to... Okay, so can this ever be... I don't think this can ever be the same digit, right? If this is the same digit as that, and it's the same region... Well, if it's the same digit, first of all, 4 and 4... Huh. Okay. Right. If they're the same digit, they have to be separate regions. So I guess I'm trying to figure out what happens if these are the same. Obviously, gray could be the same here, which would mean this is a 4 set by itself. Oh, this is interesting. Can this be... Huh. Obviously, this could be 4 there. If there's 4 this... Okay, this can never be 4 as part of the gray. Right? That's going to be problematic because this is 4, this is already medium gray because as we said, we've ruled that out. So this cannot be 4. This either 4's here, if this is gray, this has to be all the same. And this has to be all the same. So this forms 8 cells which are the same region. Obviously, this 6 would then have to be these 5 at least, and one of these 2. This would be 2 here, so this couldn't be the last part. What happens if we make this all light? So this is all light. This is 2, so this cannot be the same region. It must be medium. So then that's medium and medium, because there's no other region it can be part of. This is light, so this is 2. This can't be light. We have 1, 2, 3, 4, 5, 6. This can't be a single digit by itself, so it has to be with that. 1, 2, 3, 4, 5, 6, 7. This is full. 9. We have 4 here. We have 4 here. So this is all set. This cannot be part of the light region because these are the same digits. So it must be part of green. This is 2, so this can't be green then. So we got that. This is definite. This is definite then. This is blocked off. One of these must be light. It can't be gray, medium gray. So at least one of these is light. This has to be green because there's too many cells here. So this is 6. One of these is light. And you cannot be part of the same region, so this has to be light at least. 1, 2, 3, 4, 5, 6, 7, 8. That means one of these is green. So these are just light and green. So one of these is light. We have 1, 2, 3, 4, 5, 6, 7, 8. We have a 9th. And then we have 8 here already that are green. So any of these could be green, but the last one we don't know. So these could also be like a red or something. So green would have to all be this. That's interesting. This would be the sum of these 2. 3 would be guaranteed to be here. Green would be adding up. So this would be the same digit as that. And this would be guaranteed to be 1, 2, 4, 8. So this would be all green. One of these cannot be green because if both of them are green, so if this is gray and this were both green, then this would be 4 cells here, and that's not allowed. So this cannot be light, this is green. So we know that's a boundary. So this is green here, so that has to be a boundary, so this cannot be green. We kind of already knew that. This is red anyways. Green is one of these two. We're not sure which. This would be a 1, 2, 4, 8 triplet. Or quadruplet, so eliminates 1, 2, 4, 8 in the rest of the box, or the region. So this can't be 1 or 2. This is 3, this is 6. 3 cannot be part of the light region, so this is green, which means this can't be green, this is light. That's interesting. Huh. This obviously can't be 3 anymore. This is 1 or 5. It can't, well, it adds up. 3 and 6, that means this can't be 6 here. We have a 4, 8, 4, 8 pair in the gray region, which means this can't be 8. None of these can be 8. This is the same digit as this. It cannot be obviously 1 or 2. So this is 4, 8. This is, and then we have a contradiction. So this is 1, and it can't be in a 1 to 2 ratio with 4, 8. Because it can't be 1 or 2 because 2 digits add up to it. So that proves this cannot be the 4 gray, or 4 lights. So it's either gray, or these 4. So these two are the same region. But that doesn't help us much. Can the light actually be part of the green region? 1, 2, 3, 4, 5, 6, 7, 8, and we assume 9 or something? Then this is 1, 2, 3, 4, 5, 6, 7, 8. No. So green cannot be the same as light. Therefore, we know this has to be green. So that's guaranteed to be green. Can this ever all actually be green is kind of a question, right? This is 1, 2, 4, 8. Then this can't be 1 or 2. Right? This has to be green. We just tried light connecting, and that didn't work. Because this is 8 at most. So light has to be its own region. This must be green. This has to be medium. So can this ever be 4? 4, 2, 1, and 2. That's possible. Wait, no. If this is 4, 2, 1, and 2, the 2 would be the same, different regions. So I think this all has to be the same region then. So this must be the same region, which makes it 1, 2, 4, 8. So this is 1, 2, 4, and 8. That makes this 8. This is 4. This must be a 3, 5 pair, adding up to 8. So this is 1 and 4. That means this must be 1 and 4, or this is 1 and 4. This can't be 5 if it's light, and we know this is light, guaranteed. Or this is light. One of these two has to be light, or both of them has to be light. I guess this can't be 5. So this must be light, and this must be 1 and 4, which makes this 5. So this can't be 1, it's 3 or 5 to be consecutive with 4. These are all the same region. So 1 and 2 cannot be here. This is 4, 8. 2, 4, and 8. 2, 4, and 8. Eight, 4. Okay, so these are always the same digit. So this cannot be the same region. This is 2, so we need 1 either this way or that way. This could be medium. We don't know. So medium cannot go this way. We know this is not 4 lights. This is blocked here. This is blocked here because 2 is the most in column 2. Therefore, green has to go up here. If green does not go up here, this becomes 4 lights, and then we have the same problem, right? This can't be light, that must be medium then, which forces that problem. So this must be green going up to here to block off this light. So this could be this cannot be 4 this way. This must be 4 by itself. So this is 4 by itself. This is 1, 2, 3, 4, 5, 6, 7, 8. We have 1, 2, 3. Okay, this cannot be part of light, so this has to be green. Therefore, this is 2 by itself. This has to be blocked off here, and this is red. So this has to be light or gray. But if it's 1, 2, 3, 4, 5, 6, 7, 8, we need a fourth. We need another one, so this has to be light. This cannot be 5, so this has to be 5 here. So this is 5, this is 3, this is 5. That makes this add up to 7. So this is 7, this is 7. This can't be 1 or 5. So these can't be 1 or 5. This is not 5, then this is 8 or 9. 8 or 9, 8 or 9. That's only consecutive with 7, 8, or 9, but it can't be 7. This is 8, 9 pair, so this must be 9, 8, and 7, which makes this 6 or 8. So this can't be 8. This is 4. That makes this 2. 4 is consecutive only with 5. This is then 2, which makes this 4, because it can't be 8. This is 7, which is consecutive with 6 or 8 here. This can't be 8 because of... Oh, yeah, we already knew that. So these are 9s. This can't be 4 or 9. This is 5 or 8 here. This can't be 2, so this can't be 1. This is all green. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, but... Gray can only go to here, but it can't go to here. So this must be... This could be medium. Medium, not dark. And these are all light. So light could be here, or medium could be here. Yeah, green's all done. So these are... So we need a 3 and a 9. This can't be 3 in the green region. So this is 9, this is 3. That means these are all set. This is 4 cells. That's not possible. It's not possible. Dang it. It was looking so good. Okay, what did I do? I think this logic is all obviously kosher, right? 6, if you try to have 6 here, this is definitely part of a 6. If we try to have 6 here, 1, 2, 3, 4, 5, 6, it's part of a 5 set because it has to be. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's too large. So this has to be 6 here. So that's definitely kosher. If this is 4, maybe it's this logic here. These definitely can't be separate regions. 8, 4. Oh, wait, could be if this is. No, 4 can't be. These can't be separate regions. 8, 4. You. The question is, can these be the same region, right? Dang it. Okay, so that doesn't work. Why is this not kosher, I guess, is kind of the question. Oh, it could be 3 this way. So we know this is light. This has to be light because there's no other possibility, right? You can't go green, green. Gray can't touch it, so this has to be light. Medium gray cannot go there, so this has to be light also. We tried 4 here. Well, first of all, if this is light 2, that means this has to be 2 at most. So this can't be light, this can't be light. This is then green, guaranteed. Since this is all green, it must be 8, 4, 2, and 1. So this is 8, 4, 2, and 1 guaranteed. So this is 5. This then must be 3 and 5. This has to be 8. This is 3 and 5, and this is 4. So that's all kosher, right? Since this is not light, this has to be medium. This can't be green. This has to be light. So then we have the 4 there. But then we have problems, right? Let's just double check to make sure that those problems are still there. So this cannot be 8. This is 4. That makes this 2. This is 5 and 2. This is 7. 8 has to be missing here. So this can't be 8 or 2. No 2 or 8. No 1 or 2. No 1 or 2. No, this is not 4. This is a 4. So none of these could be 4 or 1 or 2. This is 5, 8, 9. Cannot be 8. This is 5 or 9. 5 or 9. This has to be light. These have to add up, so this is 5. So this is 5, 9, 9, 9. That makes this 1 and 4. 4, 1. This can't be 1. It's 3 or 5 to be consecutive with 4. This can't be 2, so this can't be 1 here. This can't be 2. It's 6 or 8. This is 7. 2 or 8's here. This can't be 9. 2 has to be one of these digits, and it cannot be here, so this is 2. That leaves 1, 6, and 7. He has the remaining digits in the medium gray. We have 1, 2, 3, 4, 5, 6, 7. One of these has to be light. We have 1, 2, 3, 4, 5, 6, 7. and one of these is 8. The green cannot be by itself. So this has to be green. This has to be light by itself. This can't be 4, so this is light. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the whole light region. This must be separate because this can't be green. This is green. And this is red. This can't be 5, so it can't be 2 and 3 adding up to 5. This can't be 3, so this is 2, this is 1. That makes this, what, 7? This is 5. This is 9, and we have a contradiction. Oh, this can't be 9. This is 3. So this is 5, that's 3. This is 7, 2, 5, that's 7. Okay, so there's that. 9 has to be one of these two. This can't be 1. This can't be 1. And, okay, so this is 4. This is 4. 3, 4. So that's fine. 3 here, 2 here. So it cannot go here, therefore this is green. And this must be 9. This is same region, so this is all done. Why did I run into a contradiction there? I don't even know. Anyways, what are these? This has to be 6, 8, and 9. 8 can't be either of these. So this is a 6, 9 pair, which forces this to be 8. Where did I run into a contradiction? I don't even know. I don't know where I ran into the contradiction. This is 6, 7, or 8 here. This is the same region here. So we're going to mark that as yellow. This is 3. This can be whatever. I don't know how I came up to a contradiction. I'm confused myself. Remaining digits in column 4 are 1, 3, and 9. This could be any of those. We have 5 here. So this is yellow. So the 5 has to be the yellow has to be the 5 set. I don't know how I ran into a contradiction. Anyways, so we're not guaranteed this. We're not guaranteed this. This is at least 4. This is at least 4, so we don't know anything about these. Remaining digits in row 4. Okay, this is 6 or 7. Cannot be... Oh, maybe this was the contradiction. This can't be 7 here, so this is 6. This is 6. That means this can't be 6. This is 9. That's 6. This is 7. This is 6. Oh, that's okay. That's doing so far okay. Remaining digits in row... Okay, remaining digits in row 1 are 1, 3, 4, 9. 4 and 9 cannot be here. 9 cannot be here. Remaining digits in row 2 are 1, 2, 5, and 7. That's fine. Remaining digits in row 3 are 2, 4, and 8. That's fine. Remaining digits in row 4 are 3 and 7. Interesting. Huh. 9 is... Oh, maybe it was here. 9 is only consecutive with 8. So this is 8. This is 7. This 8 eliminates 8 here, so that's 2. This can't be 2. This can't be 8. 7 is only consecutive with 6 or 8, so this is 8. Okay, 7 eliminates 7 here. This is 1, 3, or 5. So these must be adding up to 9. So this must be 9. So this is 9, which means this can't be 9. This is a different set. Okay. Where did I run into the contradiction? I don't know. This is 8 and 8. These must be the same set, so this must be 5. This is 8. This is 3. This has to be the same set, so this is orange. I don't know where I ran into the contradiction. Anyways, That's weird. This has to be 1 and 3, adding up with 6 or 8 to add up to 9. So these are the same region. Ah. But it doesn't have to be part of that. Um, I don't know how I ran into a contradiction earlier. Anyways, we showed that the other way doesn't work, so this is pretty much the only way that does. 8 cannot be here, therefore this is 8 here. This has to be dark because it cannot be orange, and this whatever region is over here has to contain an 8. This cannot be 8, so this must be part of the same region as this. So we're going to mark those as blue. Therefore, these two must be the same region. Right? So we have 6 here. Okay, so this cannot be the same. I mean, yellow technically could go that way. It's going to cause some problems, though, if it does, I think. I don't know. Obviously, yellow cannot be all the way here, because that would block red off. Unless this is all the same region. So we have 4 already in row 1. We have 4 in row 2. We have 3 in row 4. We have 4 in row 5. Red cannot be 3. This cannot be 3. This cannot be the same region because we have a 7. This could be orange. No, it can't be orange. Okay, what are the possibilities here? So this has to be 8. Rest of row 6 is 1, 3, and 6, right? This can't be 3. If orange, 8 and 1, this can't be 9. Okay, rest of column. Okay, so this can't be 7. So the remaining digits in column 7 are 1 through 5. Which means 8 is going to be the largest one. So this cannot be orange. Therefore, for a set of 3, these have to be the same set. It could be yellow. It still could be yellow. This cannot be the same as this, though. So this is blocked off. This is its own separate region. These two must add up, so this is blue, which means this is blocked off here. This is separate than that. So these could be the same region. So these are not, these are a different region. This is a separate region, so that's blocked off. This must add up to 8. It must be 3 and 5. That eliminates 3 and 5 in the rest of the column. Okay. This is a 1, 3, 1, 3 pair in column 6, which eliminates 1 and 3 in the rest of the column. So this is 5. So these cannot be 5. This must be 1 and 7 adding up to 8. This is 6. This can't be 1 or 6, so that's 3. Rest of column 1, we have, what, 2, 4, and 5. Rest of this can't be 2 because of the 2 in the row. Rest of column 2 is 1, 6, 9. 9 cannot be here. Rest of column 3 is 4, 6, and 8. 8 cannot be here. This can't be 1. This can't be 3. Okay. So far, this is looking fine. These are the same region. This has to be yellow, so these are the same region. It cannot extend to here. So it's likely this is the same region here. This is not the same region, so that's blocked up there. But this could be 8. Okay. This has a 6. So this blue essentially must go up here. Okay, we're going to mark this blue as pink, essentially, I guess. So pink has to go up because we need access to a 6. So it must either go up here or here. Because otherwise this 6 doesn't have a region to go to, right? Say these were separate regions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this cannot be 2 full regions by itself. So pink has to go here because there's only one other region here. That means it accesses a 9 somewhere. So it's 9 and 6 and 9 and 6. The other one is dark. So one of these is pink, the other one's dark. This is 3, so this can't be 3. This is 7, which means this can't be 7. This is 2. This can't be 2, so that's 1. This can't be 1 or 2, so it's 7. This 1 eliminates 1 here, so it's 4. That makes this 2, which makes that 4. This can't be 4 here. This can't be 4. This is a 3-5 pair, adding up to 7. This is likely just a blue region, then. We're going to mark that as blue. This has to go out. This is only 8 so far. Actually, how many? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. We need 26 and 27 to add for 3 regions. So this must go at 3 times. It has to go at least... It can only go to here at these 2, so it must go to here, to one of these. So this must be the same region, which means this is the same. Doesn't have to be. Yellow. Oh, yellow can't go here. What other region can go here? It must be blue. So this is blue. Must be these. Okay, so this is 1, 2, 3, 4. Okay, so again, we have 6. This is 24. Right? We have access to 3 more, which gives us 3 regions, so that's 27. This is not... This is dark, right? Yeah. So that's 27. That means there's 4 left over for blue, so this cannot be blue. This has to be yellow. Interesting. Okay. This is 3 and 5, so this can't be 3 or 5 because of the 3-5 pair in the region. This is 1 and 8. That makes this not... This is 7. So... This is 5. This has to be part of the 5. This must be other part of the 5. Oh, but this is 7. No, we have a contradiction. No. No. Oh, wait. No, this is part of there. Okay, so this is part of the yellow. So we have 1, 2, 3, 4, 5, 6, 7. This can't be yellow. This has to be red. So this is part of this. Yes, there we go. So this is part of this. This has to connect this way. This must be its own separate region. We don't know where the yellow goes down to. It goes somewhere. The red has to go here. The blue is blocked here. Pink has to go to here. Well, we don't know. Okay, so this is 5. This has to be 5 here. So this is blue, and therefore this is all blue. So this is all done as a region. Therefore, this is what? 2. This 1 eliminates 1 here, so that's 3, which makes that 1. 3 eliminates 3 here, so that's 5, which makes that 3. This can't be 1. This can't be 5. This is a 2, 4, 5 triplet, which eliminates 2, 4, 5 in the rest of the region, so this can't be 4. This 1 eliminates 1 here. Where is the 1 in column 2? It must be here. So this is 1. This cannot be yellow. This must be red then. So we have 1, 2, 3, 4, 5, 6, 7, 8. So this is a boundary. The rest of blue region must contain 2, 4, 6, and 9. 2 cannot be here. 6 cannot be here. We have a 2, 4, 6, 9 quadruplet in row 9, which eliminates 2, 4, 6, 9 in the rest of the row. So this can't be 6. This is 8. This can't be 8. We have a 4, 6, 9 triplet in row 8, which eliminates 4, 6, 9 in the rest of the row. This can't be 4, 9. This is 2. So this can't be 2 here. This can't be 2 or 4. So this is 5, which makes this 4, which makes this 6, which makes that 4. This 4 eliminates 4 here, so it's 2. This cannot contain a 6 or 9, so this cannot be yellow. This is red, which forces this to be yellow. This is a 6, 9 pair. That's fine. This can't be 4. This can't be 4 because of the 4 in the column, so this is 9, which makes this 6, which makes that 4. This 9 eliminates 9 here, so that's 6 and 9. This 9 eliminates 9 here, so it's 1, which makes this 3, which makes this 9. And we're essentially done, but we want to do the boundaries. These are boundaries, so we already knew that. So orange, okay, this is 5. It cannot have access to a 3 or 5, so this cannot be orange. This must be then 6 in length, so that's 6 by itself. Therefore, this is a boundary, and it must be part of pink. So we have a 3, 5 pair that's part of pink. We need access to a 4. So this is pink. Orange. Okay, so this cannot be pink because this would be 4 pinks there. So this must be dark, which means this can't be dark. This is the pink. This has access to... This cannot be 3, so this can't be pink here, which means this is pink. This is orange. And we need access to a 2 for the orange. So this is orange then. That means the rest is dark. And let's check if that makes sense. We have 4 cells is the most in row 1. 4 cells is the most in light in row 2. We don't have anything for row 3. For row 4, 3 has green has the largest with 3. In row 5, green has the largest with 4. In row 6, pink has the largest with 3. Row 7, yellow has the largest with... Oh, we missed the boundaries here. So this is boundaries. Yellow has the most with 5. In row 8, blue has the most with 5. In row 9, red has the most with 5 here. Column 1, red and green have the most with 3. In column 2, we have light, green, yellow, and red with only 2. Column 4, we have 3 in light, and that's the most. In column 5, we have 6 in medium. Column 6, we have pink and dark with 3. Column 7, dark has 3. Column 8, we have dark with 2, pink with 2, and blue with 2. And column 9, we have 6 with orange. 8 adds up to 3 and 5, which adds up to 8. 5 adds up to 4 and 1, which adds up to 4 and 1. 7 adds up to 5 and 2, which adds up to 7. 6 adds up to 6 to 6. 9 to 9 to 9. 7 adds up to 5 and 2, which adds up to 7. 8 and 1 adds up to 9 and 9. 8 and 8 add up to 5 and 3. And 8 adds up to 1, 7, and 3, 5. 8, 4, 2, and 1 is in a 1 to 2 ratio. 5 is consecutive with 4s. 3 and 4 consecutive. 4 and 8 is a 1 to 2 ratio. 2 to 1 is 1 to 2 ratio. 7, 6, and 5, 4 are all consecutive. 4 and 2 are in a 1 to 2 ratio. 7, 8 is consecutive. 7, 8, and 8 and 9 are consecutive 2 and 4s and 1 to 2 ratio. So this must be 3 and this is 5. And that's how you solve it. That wasn't too bad. I don't know. I got to a scenario where I basically ran into a contradiction when I didn't. I don't even know how I ran to that contradiction. I think I made this an 8, maybe. I forced that to an 8. Maybe that was it. I don't know. But yeah, it didn't seem too hard. There was just basically some pretty logical explanations that we had to come with, right? The hardest part probably was basically figuring out what these scenarios had to be. But that was pretty much it. I would probably label this as hard. Not very hard, but hard. Any chaos construction is always challenging at the minimum. I don't think I've ever seen an easy chaos construction. Unless you make the rules very, very simple. But yeah, this was substantially difficult, but I didn't think it was overly difficult, if that makes sense. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.